Yes, my students. So next we have the topic derivation of equivalent current, torque and power methods for fluctuating and intermittent loads. Equivalent current calculation, equivalent torque and power values we have to calculate now. For fluctuating and intermittent loads. So in case of fluctuating and intermittent loads, what happens here is that as load varies, load will vary with a time interval. So load will vary with a time interval. So whenever load varies, so load varies means what? Current in that motor will vary. Current in the load will vary. So load variation takes place nothing but current will vary in that. Current in terms of current again, so whenever in case of fluctuating loads, we can say there is a load variation takes place in the different with a time interval. Whenever load varies, current will vary. Current will vary, torque will vary. Torque will vary, power will vary. So all are dependent each other. So in that case, what happens here is that so we need to calculate the equivalent value. These equivalent values are required to select the motor rating. For a selection of motor rating, this equivalent value we have to calculate. So what is plot indicates here is that so it is plot indicating the current versus time. For a different time interval, we have the different currents. Means what? So in case of fluctuating load, so load will fluctuate. Whenever load fluctuates, current also varies with a different interval of time. So we may randomly we can draw here. So just I have drawn here. You may draw it randomly. There is no any specific rule for this one. Only thing is that current has to vary. That's it. So now fluctuating load is considered of n value, total n value of motor currents I1, I2 up to In for a duration of T1, T2 up to Tn. So up to nth time variation we have considered. Next we have so how to calculate this equivalent value then? So equivalent value we are calculating using one method. So loss we have calculated here. Total loss we have calculated. Loss includes what? There are two types. One is the iron loss, another is the copper loss. Iron loss nothing but it is the constant loss. You can say it is PC. Copper loss is nothing but it is the variable loss. You can say it is I square R. So what is R here? So whenever load motor is present, definitely there is a winding, there is a resistance to current flow. So that we are indicating as a R here. So that gives the I square R loss. So total loss of each part we have considered. For each part loss we have considered. For first case, copper loss plus iron loss, constant loss plus I square R loss in the time interval of T1. Constant loss plus I square R in the time interval of T2. So up to that n we have calculated. So total time period is T1 plus T2 equal total Tn we have considered. Next what we have done is that just we have open the bracket. So T1 will multiply in all cases. So open the bracket, just make the rearrangement, will get like this. This can be divided into it can be written in this can be divided like this. There is a it is mathematics, just to go through that. So just we have rearranged like this and we have got this much equation. So what happens here, this bracket part and this part will cancel here, only PC remains as it is. So after this box remains as it is, and in place of R here and R here, this total equation is resembling this part. So PC plus I equivalent square into R. In place of PC we have PC, in place of R we have R, in place of I equivalent square what we have is that we have this equation we have this equation I1 square T1 plus I2 square T2 plus I square into Tn. So once you write, you will understand them. Just keep on writing the things while seeing the video. That is important thing. Even we can calculate with the integration also. Area under the curve we are calculating. So that's also possible here. That is the, so like this we have calculated the current equivalent. Current equivalent we have calculated. Similar to this current, even we can calculate the power also, torque also. Torque equivalent, in place of current, just replace current by T, we'll get the torque equation. Next, in place of T, just to replace power, we'll get the power equivalent. That's it. So now what we have calculated? Three parameters we have calculated. One is the chi equivalent, T equivalent, P equivalent. These three parameters we have calculated. Along with that, we need to study one more important thing, is that this part we have to remember. Overload current capacity of the motor. Overload current capacity of the motor means what it is, how much overload is possible on that motor. So whenever a load variation takes place, so current will vary. So in that case, how much overload current it can carry, that we have to calculate. So it is nothing but what it is representing by lambda. It is maximum current by rated current. Maximum by rated. For example, say it is 2. For a DC motor, it is value is 2. So you can write Imax by I rated is equal to 2. So you can write like this: Imax is equal to 2 times of I rated. So what is meaning is that whenever load variation takes place, so whenever high current will flow in the motor, it can carry only 2 times of the rated value. It's how much it is having capacity, it can carry only 2 times of the rated current, not more than that. If current is more than that, motor may burn. So that may happen. So for example, say examples, take I rated is equal to 10 amps. So maximum current it can carry is 20 amps. That's it. So like that, it defines the overload capacity of that machine. For a different machine we have different values. For induction machine we have different values. For a synchronous machine we have different values. So this can be used for the calculation of in case of problem calculation, we'll understand this concept, overload capacity factors. It is useful for the calculation of rated value calculation. It is really useful. So this is how we have this derivation: equivalent, current, torque and power calculation. This is the derivation. Thank you.